we have decided we're not going to patent this mutation. As I said at the beginning, I consider it very much a community effort, and I think patenting it would be inappropriate. So once that publication appears, anybody who wants to actually can use the information that will be in the paper and set up their own DNA test. That will invariably happen, so probably before the end of 2010, this hopefully will come out in print, and you may find that there's other DNA testing facilities around the world that start to offer this test. That's fine, that's perfectly legal for them to do so. I will just say that if they do so, they are doing so independently of the Animal Health Trust, and the Animal Health Trust will have no control over the quality of their test. So once we found that mutation, and we used miniature terriers and Lancashire Heelers for the main bulk of the research, we did have a big bank of DNA from other breeds, also with primary lens luxation. So we looked at all the affected dogs from those breeds and found the mutation so far in all those breeds you see listed there. And I suspect the list will continue to grow slowly but surely over the years, or the coming months. So an enormous range of dogs. And again, many of them terriers, but some of them not traditional terriers. You've got the Australian cattle dog there, which was a bit of a surprise, and the Tibetan terrier, which apparently is not a true terrier, the Chinese crested as well. So a few breeds as well that suffer from primary lens fixation which do not have this mutation. So Shar-Pei, for example, does not have this mutation, although they do, as a breed, suffer from primary lens fixation. So that just tells us they must have a different mutation that is causing the same condition. So I get asked a lot of times, how is it that it's in so many different breeds? Did it arise independently in all those different breeds? And I think the answer to that is almost certainly no. This slide is an attempt to illustrate what I think probably happened and how that mutation is in so many different breeds. The founding dog that had that original mutation that I talked about, I suspect, was not one of the breeds that we particularly recognise today. I think it was probably a long time ago. I've shown it sort of as a wolf there. I don't think it was quite as long ago as when all dogs were wolves, but maybe a more generic dog, or in a dog of a particular breed, but before the breeds were as isolated as they are today. And what I'm attempting to show here is that founding dog, we know he or she reproduced, otherwise we wouldn't still have the mutation around today. But possibly amongst his offspring there was a bit of variation. I'm trying to show you here is that, so this by the way is the DNA, and this red circle illustrates the mutation, and the clear circle illustrates the normal copy of that DNA. So this dog reproduced, and I don't know, some of the dogs might look quite like the parent, but maybe with a bit of size variation in there. The dog on the right, it looks quite like a wolf, but it's maybe not quite the temperament of its parents, a bit more low fat. The dog on the left, still fairly wolf-like, but looks a little bit different, and maybe that dog would have been selected to progress into the development of slightly different breeds. So I'm showing this progression quite quickly so I can fit it all onto one slide. Each one of these generations I'm sharing might have actually been multiple generations. So let's say that dog on the left, which happened to inherit the lens luxation mutation, also reproduced, and the variance among his offspring gave rise also to different lines, different breeds, or were passed into different breeds. Dogs that didn't inherit the mutation, such as that dog on the far left, this dog over here, didn't inherit the mutation, so all his offspring will be clear of that mutation. Whereas some of the others that did maybe gave rise to dogs that paved the way for other breeds. And down here you've got this sort of, some sort of generic terrier, which, whose offspring maybe went into old mutation happened a very long time ago and has passed into the different breeding stock or the different gene pools that founded different breeds.
Could I ask you why you think it would be variable and not attributable to perhaps when we're trying to breed, if you like, different bleachable terrier, Staffordshire terrier, and there'd be interbreeding at that stage?
I mean, I think that's another possibility. I mean, the way I'm thinking of it is that because it's in so many different breeds and it's actually very prevalent in many different breeds. I almost and the studies we've done so far indicate that the chromosomes that all these different breeds have got are, if you like, the piece of red chromosome surrounding the mutation is about the same length in the breeds that we've studied in depth. If it had passed very recently into a breed, you would expect them to have a very long stretch of red chromosome either side. I suspect a little bit of both has happened, however. And for example, the Lancashire Heeler people swear that there was they caught their mutation from a Jack Russell, and I think they've got a particular Jack Russell in mind. So it's probably a little bit of both, actually. And some breeds possibly did get their mutation as, it could be a one-off, rogue breeding that occurred. And, we see, for example, we've identified a mutation that causes hereditary cataract in Staffordshire Bull Terriers, also in Boston Terriers, also in French Bulldogs. And I think, possibly what happened there is, you've got a rogue, maybe a breeder who, likes that type of dog, has got Staffordshire Bull Terriers and Boston Terriers, and, something happened by mistake or intentionally, and that passes the mutation. So I think you've probably got, you could have both scenarios going on. You've just got so many almost different types of dog as well. So you've got, the Australian Shepherd and the Chinese Crested, and it's in quite a diverse set of breeds, and that suggests that it happened a very long. Another example that somebody might be familiar with is the PRCD form of PRA that Octogen does a DNA test for. That's a form of PRA that's in, again, about 20 different breeds, Labradors, Poodles, seemingly unrelated breeds. And so the only way you can really realistically explain that is by something that happened. I mean, it wasn't as long ago as the book, but it was that, just trying to sort of illustrate the point, but relatively long time ago. Okay, so we have a DNA test. The Animal Health Trust made their test available on the 19th of October, so just about 4 weeks ago. Below here are what the results look like to us in the laboratory. Very simple to distinguish. If your dog has a result like this, we know it's a clear. This result here indicates a carrier, and the result down here that looks like this indicates that the dog is genetically affected. So I'm sure all of you have probably made use of this facility already, but that at the top is the website if you wanted to find more about the test. Kits for taking cheek swabs are available on that phone number or at that email address. And there's an email address, DNA testing is NHT, for just sort of general information. I will say that actually the team behind those email addresses is a very small team of people who have been absolutely overwhelmed by the enormous interest in this test. And in the 4 weeks that it's been running, they've had about 2,000 requests for the test from all different breeds. So they're very, very overwhelmed. So I will just put in a plea on their behalf that if you are waiting for test results or waiting for information, please be patient with